Dear friends, Mass Aspirants Groups organizes several online problem solving sessions and online programs to help the students who are preparing for different national level competitive examinations like IIT JAM, CSIR NET, GATE, NBHM, etc. Today, we are starting this year's classes which are focusing the IIT JAM examination. Today, we blessed to have Mr. Rajendra Rajpurohit with us to handle a problem-solving session. It is designed as moreover a problem-solving session, but in this session, he will explain the preparation strategies for cracking IIT JAM examinations, and also he will explain these tricks through selected problems from the last JAM examination. So I am very happy to introduce Mr. Rajendra Rajpurohit to our members. He already taken some classes in our platform. Mr. Rajendra is currently pursuing PhD at IIT Roorkee. He qualified CSIR NET and JRF with very good ranks many times, and also qualified GATE examination, and also cracked PhD entrance examinations for several IITs. And also he has taken many online classes to CSIR NET aspirants through his YouTube channel. And I'm sure that today's session will be really very helpful in your preparations, especially in shaping your preparations in the right direction. So you will be after the session, there will be an interactive session. At that time, you can ask your doubts about your preparations and all that. Mr. Rajendra will be here to help you to model your preparations in the right track. I welcome everyone to this program, and I would like to express my sincere thanks and gratitude to Mr. Rajendra for being with Math Aspirants community and also for engaging this type of sessions in our platform. I welcome everyone to this program. Welcome, Rajendra.
Thank you for pointing that out. Thank you, sir, for the introduction, and very welcome all of you to this session. As sir explained that this session is introductory, as well as we will do some problems from the very last exam of IIT JAM, which is precisely 2024. So in the meantime, if you have any query, any questions, if you like have a query about what I am going through right now, you can just raise your hand, or you can just directly unmute and ask your question. And if you have any question in general, you can just simply put it into the comment section so that we can discuss it later on when we are done with the session. So let's just start then. Okay, so IIT JAM. This time for 2025 exam, the conducting agency, or I would say the conducting university or college, will be IIT Bombay. But let's talk about some detail of this exam. So what are the eligibility criteria if we look for the very first thing? So I mean, you just need to be in BSc final year, or if you have already done your BSc, that is also great. And I think percentage criteria is 55% in some of them, and some of them just want you to qualify the JAM exam with good rank, all the IITs. And if you look at the exam, it's once conducted yearly, mostly in February or March, at most March. And if you look at the paper pattern, so this is the paper pattern for your exam. You have like 3 sections in total. Section A contains 30 questions, and 10 questions each carry 1 marks. And for these 10 questions, you have a negative of 1/3, means 0.33 marks. Not exactly 0.333 infinite sequence. So 1/3. I mean, like if you do 3 incorrect, then your 1 correct is gone with them. And there are 20 questions in section A only, which each carries 2 marks. So this section actually contributes 50 marks in your exam. And there are negatives in this as well. And same again, 1/3 of the actual marking, right? So 33% something negative for each incorrect answer. Then there is section B. These all are MCQs, and that explains that it has negative marking. Okay, these all questions are MCQs. Then in part B, you have MSQs, multiple select questions, they call it, or like one or more options can be correct. There are 10 of them. Each question carries 2 marks, and you have 20 marks in this part, and there are no negative marking. Section C is purely NAT, numerical answer type, where you have to give your answer in a value, and it also contains your 20 questions in total, and 10 for 1 marks and 10 for 2 marks. So this is therefore 30 marks, and again, since it is NAT, there is no negative marking. So that's your total 100 marks and 60 questions in JAM exam. Now, like the paper pattern looks very easy, and if you look at the syllabus and all, let's go to that part. If you look at the syllabus, you have real analysis, in which mostly you have sequences and series of real number, and syllabus is written very precisely. You can find it on IIT's website itself, like IIT Madras has published this. I have taken it from there. So they have specifically mentioned like these are the topics you have to go through, and then function of one variable is there, that is also in real only. So limit, continuity, differentiability, Rolle's theorems, and this all fundamental theorem of calculus is there. Riemann integration is also there. So this. And then if you move further, you have multivariable calculus and differential equation. So I consider this 2 variable in real analysis only, because limit, continuity, partial derivatives and total derivatives, and maximum minima are just finding partial derivatives and applying some tests. So again, this I think this should go into this real analysis part only. Then there is integral calculus and double integral, triple integral. Some standard formulas are there which you have to remember if you want to do question from this part. Differential equation, so precisely written, you have what kind of differential equations you have to go through, and I think Rajendra is more than sufficient for this content. So that is all. That's it. Just syllabus is like very little. And now if we look for the marks distribution, I think algebra is missing here. I don't know where it goes this year. Yeah. So linear algebra and algebra is there. Matrices, where you just have system of equations is there, rank nullity theorem and inverse determinant, eigenvalues, eigenvector. Very standard linear algebra which you go through in your very first year. Then the vector spaces and their finding Li, Ld and basis, finding dimension calculation or dimension analysis, I'll call it, linear transformation, basic properties of linear transformation, and so on. This is also there. Then in group theory, you have appeal homomorph, group homomorphism. I think this all is your first year syllabus. Okay, now let's talk about what mark reservation is there for this exam for IIT JAM for each subject. So I have calculated the marks for the most recent exam, which was in 14 only. So from group theory, there were I think around 14 marks were there in your exam. 14 marks in total, part A, B, C, whatever you consider. And now just before moving further, let's talk about cutoff. So group theory alone was there of 14 marks, and the cutoff for mathematics was 11.22 marks out of 100. Okay. And that too for general category. So I mean, do you see 14 marks for one subject, and then the cutoff is 11.22 marks. So I hope you understand the level of depth with the question which were asked by IIT Madras. Anyways, linear algebra is again 18 marks, if I remember correctly. The marks can vary from 2 to 3 marks, not much variance. This part was for almost 18 marks in your exam. Again, if you single-handedly do one subject precisely from the depth, this will be sufficient for you to qualify the exam, not getting admission though. Okay, and let's talk about this part. So let's consider this as first, this as second, and this as third. These combined contributed 40 marks in your exam. So I mean, if you have real analysis alone, this I'll call these 3 units. If you have these 3 units alone, you can just get whatever university you want. Integral calculus 7 to 8 marks as usual, and D was there for 13 to 14 marks. I don't remember correctly. These all calculations are like can vary from 2 to 3 marks at most, and they are from the last exam, like most recent one. So this is the marking criteria, the marking reservation for each subject in your IIT JAM exam. Now, if you look for the topper of this exam from the mathematics category, this is rank 1 person in mathematics. He scored 57.33 marks out of 100. That is rank 1. Okay, and the cutoff is 11.22. What are the reasons why the cutoff is very down? I mean, why not even 36%, which is passing marks for university level? Why the cutoff is not even that? I think that the paper was of good level this time. Generally, the cutoffs are in between 20 to 30 marks. I don't remember ever it going above 30 marks. So how do you start preparing for this exam? If you are in your second year or third year in BSc, then I think BSc or BA or your graduation course, then I think very ideal time for you. If you have completed your BSc or master's and still you want to write this exam, still fine. I think you need almost around 6 to 8 months properly, 6 to 8 hours study every day consistently, and you can join some lecture series. All the content you can find online or on the YouTube, and yeah, that will do for you. It's very simple and yet very hard, because you have to do the same thing every day. Go through one chapter, make the chapter of this syllabus. You can ask for help from me or anyone if you have in your contact. Take one chapter, finish it, do 40 to 50 problems on that chapter, move on to the next chapter. Like entire real analysis, you can break it into 7 or 8 chapters. Like if I were you, I would be breaking it like this. Like the first one will be like point set topology, where I can go through closed set, bounded set, limit points, and so on. Second chapter, I'll be breaking it into sequences, and third will be series, and then I can go through limit of function. That will be fourth chapter. Then I can go through continuity, then differentiability, then this Riemann integrable integration chapter, and uniform convergence is not there for you. Then I'll go for function of two variables. So that will be like 8 to 10 chapter at most for real analysis, right? So you can break a subject into chapters step by step, finish one chapter, do 40 to 50, even 100 problems on that. Discuss the problems with someone. That will be very helpful for you. Discussion is must in mathematics. If you are doing mathematics alone and preparing for a competitive exam, then it will be very difficult for you. If you have a partner, it will be very helpful. Okay, so I strongly suggest you to get a small group of people where you can discuss. And one of the group will be this WhatsApp group of math aspirant itself. You can put your problems and you can pick out those people who are continuously active and replying to your queries, and make us, you can start discussing with them. So you can pick people from there for your own benefit, mutual benefit, I would say. So what will be the cutoff for getting into IIT? I think your target should be 40 or around 40. And if you are, unless your target is like getting rank 1, you should pick 1, 2 or 3 subjects. If I were you, I would go for, because I am good in pure mathematics, so I'll go for real analysis, I'll go for algebra, and I'll go for linear algebra. And if I complete these 3 subjects uh, properly, I can score 60 marks. I mean, the marks reservation is more than 60 marks for these 3 topics. So I don't think there is a problem of how do you get it? The problem is that you have to put efforts continuously and you have to go through the content very deeply. All right, now, so I think that is enough introduction and preparation strategies that I can tell you for today. Now we can go for the question paper, and we can go through the some questions of the previous year exam. I have picked both kind of questions, easy and difficult together. And so, yeah, if any of you have any queries, you can ask now about preparation, and then we will go for the question answer session. So, anyone?
Sir, my name is Ramakant. I'm coming from St. Paul's College. Sir, I had a question on preparing about real analysis. What book do you suggest, whether to go for an Indian author or for foreign author?
If you are looking for IIT JAM, I think that and you are beginner, then I think I would suggest you an Indian author in the beginning. Okay, I mean you can go for S.K. Mappa or Santina, and these are like, or Malik, even any of them you can pick, and they will be sufficient for your the theory part. And for practice, I would suggest you to go through some coachings notes or some assignment sheets from the coachings. You will find them all online on the internet, and I'm sure that you must be that active to get all those questions. So yeah, in the beginning, if you are beginner, then strongly I would suggest you to go through Indian authors. But yeah, again, I would not recommend you to go through one by one chapter and each and every theorem and everything. Okay, you have to be precisely choosing those topics which are in exam, and do their exercise and try to understand the concept which are in your syllabus only. Okay, and you can refer another book in your preparation, which will be the Robert Bartley Introduction Real Analysis. So that you can keep it as a backup book. Like if you are not getting something in here, there is one topic or something, then you can refer to that book.
Thank you, sir.
Yeah. All right, then shall we start question answers then?
Hello, sir.
Yes.
Sir, how to, sir, all concept clear in group theory, real analysis. But sir, this time I am already, sir, पूरा रियल एनालिसिस में पढ़ चुका हूँ लगभग. ग्रुप थ्योरी भी सर कंप्लीट हो गया है, रियल एनालिसिस कंप्लीट हो गया है. बट सर क्वेश्चन में सर कॉन्सेप्ट में कैसे यूज करें, ये सब थोड़ा प्रॉब्लम होता है.
ओके, तो आपका क्वेश्चन है कि आपका थियरी पूरा हो चुका है, बट यू आर फाइंडिंग डिफिकल्टीज इन सॉल्विंग प्रॉब्लम्स, है ना? तो एकदम बेसिक पे जाओ. बेसिक पे मतलब पुट थियरी इन फ्रंट ऑफ यू, एक साइड में थियरी. लेट्स कंसिडर अ टॉपिक, like let's consider continuity, and there is a theoretical question of continuity. जो क्वेश्चन पूछा है, जिस कॉन्सेप्ट पे क्वेश्चन पूछा है, उसका थियरी सामने रख लो. चीटिंग इज अलाउड इन द बिगिनिंग फेज, एंड देन ट्राई टू सॉल्व इट. ठीक है. दूसरा चीज, सॉल्यूशन के पीछे नहीं भागना स्टार्ट कर दो तुरंत क्वेश्चन आते ही. स्पेंड सम टाइम ऑन अ प्रॉब्लम, खुद से मेहनत करिए. उसको एक क्वेश्चन मिल गया है, उसको लेके बैठिए, थोड़ा आधा घंटा 1 घंटा उस पर दिमाग लगाइए. फिर भी नहीं हो रहा है, देन सीक हेल्प. डायरेक्ट आंसर ढूंढ के उसको समझने की कोशिश नहीं करिए. उससे प्रॉब्लम ये होगा कि आप एग्जाम में क्वेश्चन नहीं सोल्व कर पाओगे, खुद का थिंकिंग प्रोसेस डेवलप नहीं हो पाएगा. क्वेश्चन में भेजामारी करिए थोड़ा ना. ट्राई टू स्पेंड लाइक 30-40 even hours on a single problem and try different method. एक क्वेश्चन उठाए, उसको कैसे कर सकते हैं ये, क्योंकि आपने एक बार गो थ्रू कर लिया है, तो यू मस्ट नो सम मेथड्स कि इस टाइप का क्वेश्चन ऐसे किया हुआ है, वैसे किया हुआ है. यू ट्राई ऑल दोज इन दैट क्वेश्चन. ठीक है. अगर वहां पे भी दिक्कत हो रही है कि आपको पता ही नहीं लगा स्टार्ट कैसे करें, then go through some solution series. You will find pretty much on YouTube the people solving question, like you can find mine as well, where how other people are starting to solve the problem, कि सोचने का तरीका क्या है, कैसे स्टार्ट कर रहे हैं प्रॉब्लम को सोल्व करना, है ना? वो अगर आपको एक बार आ गया, पेन उठा के प्रॉब्लम सोल्व करना स्टार्ट आ गया, दिमाग चलाना आ गया, तो फिर कोई दिक्कत नहीं है. उसको कैसे अचीव करना है, उसके लिए आपको प्रैक्टिस. तो प्रैक्टिस कहाँ से करोगे, वो आपको खूब सारा कंटेंट ऑनलाइन मिल जाएगा, है ना? तो रोज प्रैक्टिस करना स्टार्ट करिए. आप प्रॉब्लम सोल्व करिए, आप खूब सारे, लाइक इवन मेक अ टारगेट टू 60, 70, 80 प्रॉब्लम अ डे. Try to solve them. Okay, that will help.
Sir, सर जैसे कि अभी हम लोग का बैचलर सर अभी मतलब पढ़ाई हम लोग बैचलर का अभी कंप्लीट नहीं हुआ, इसमें सर बीच बीच में सर जैसे सेमेस्टर एग्जाम मिड टर्म होते रहते हैं सर, तो उसके साथ सर जैम का मतलब कैसे क्लियर कर सकते हैं? मतलब तो कर तो सकते हैं, पर सर सेमेस्टर एग्जाम में भी सर पढ़ना पड़ता है, अब जैम का भी तो पढ़ना पड़ता है। अभी सर इस समय जैसे सेमेस्टर एग्जाम सर स्टार्ट है, तो मतलब मैनेज करना सर थोड़ा मतलब सर मतलब ट्रिकली हो जाता है, पर मैंने नहीं हो पाता। जैसे सर अभी किसी का बैच लिए हैं तो सर इसमें मतलब सर एग्जाम हो रहा है तो सर बैच का छूट जा रहा है, मतलब सर मैनेज कैसे करें ये भी एक बहुत बड़ा क्वेश्चन है।
हाँ, इट इज अ प्रॉब्लम और मैनेज करना डिफिकल्ट है, इसीलिए तो कट ऑफ कम जा रहे हैं। अगर आसान होता तो कट ऑफ भी ऊपर जाती और बहुत सारे लोग कर रहे होते हैं। ठीक है, सो इट इज डिफिकल्ट, यस आई एग्री, डिफिकल्ट तो है। एग्जाम टाइम में थोड़ा सा आपको रिलैक्स मोड में आ जाना है जैम की तरफ से, और इन जनरल आपको वो वाले टॉपिक उठा के पढ़ने की कोशिश करनी है, स्मार्ट प्रिपरेशन, है ना, कि जो सिलेबस से इंटरसेक्ट कर जा रहे हैं, अगर वो ऐसे टॉपिक्स हैं तो उनको आप अच्छे से फिनिश कर लीजिए, क्योंकि आपके वो ग्रेजुएशन में भी काम आ रहे हैं और जैम में भी काम आ रहे हैं, उनको आप पहले प्रिपेयर कर सकते हैं। बाकी आई थिंक 2-3 घंटे निकालना, अगर आप ग्रेजुएशन में हैं, अभी क्लासेस चल रही है आपकी, थिंक 3-4 hours यू कैन मैनेज, एंड दैट इज ऑल यू हैव टू मैनेज स्पेसिफिकली फॉर आईआईटी जैम अलोन। ठीक है, वो आपको सेपरेट करके रखने पड़ेंगे, उसमें फिर कोई वो नहीं होगा। 3 घंटे 4 घंटे तो आपको रोज देने पड़ेंगे, है ना? वो आपको बीएससी से अलग करके।
सर अपन सारा सिलेबस कहाँ से कवर कर सकते हैं? मतलब अपन यूट्यूब पे गए तो वहाँ पे बहुत बहुत सारे लेक्चर्स टीचर्स रहते, मतलब अपन वहाँ जंबल हो जाते।
आई स्ट्रॉन्गली एग्री विथ विशाल। कंटेंट इतना सारा है अवेलेबल कि जेन्युइन कंटेंट पिक करना इज वेरी डिफिकल्ट, है ना? तो उसके लिए तो देखो, आई वुड सजेस्ट यू टू, यू नो, इफ यू कैन मैनेज सम नोट्स और समथिंग ऑफ सम कोचिंग सेंटर, दैट विल बी वेरी हेल्पफुल फॉर यू, है ना? आप उसके करस्पॉन्ड पढ़ते जाइए, कोई टॉपिक नहीं समझ में आ रहा है नोट से, वो फिर आप तुरंत उसको सर्च करके पढ़ लीजिए। तो दिस विल बी लाइक कि इन केस यू आर नॉट ज्वाइनिंग एनी कोचिंग सेंटर, दैट विल बी वेरी हेल्पफुल फॉर यू। कोई कोचिंग के नोट्स मैनेज कीजिए, मिल जाएंगे बहुत सारी जगह से। ठीक है, कोचिंग के नोट्स मैनेज कीजिए, नोट्स को पढ़ते जाइए, नोट्स में जो चीज नहीं समझ आ रही है वो यूट्यूब पे देखिए पर्टिकुलर, एंड कम बैक टू नोट्स, नहीं तो भटक जाओगे। ठीक है, अब वो टॉपिक कहाँ से समझ में आ रहा है, कौन पढ़ा रहा है, कैसे समझ आया, जिसका आ रहा है उसका देख लो, है ना, क्योंकि हर टीचर का अलग अलग पढ़ाने का पैटर्न होता है और समझने का भी स्टूडेंट का अपना पैटर्न होता है। जहां से आ जा रहा है कर लो उसको। ठीक है, दैट विल बी वैलिड सॉल्यूशन टू दिस। नहीं तो मार्केट में भटकते रहोगे, ऐसे यूट्यूब पे ऐसे ढूंढते रहोगे कि स्टार्टिंग से लेकर लास्ट तक पूरा सिलेबस कोई पढ़ाते, आई थिंक वेरी डिफिकल्ट टू फाइंड। और मेरे दिमाग में ऐसा कोई एजुकेटर अभी तो नहीं है जिसने पूरा सिलेबस यूट्यूब पे करा रखा है।
सर जो
सर
प्योर मैथमेटिक्स सर
वन
जो
मिनट।
प्योर मैथमेटिक्स में है, जो थ्योरम्स है, उसको
हाँ,
प्रूफ उसका प्रूफ इम्पोर्टेंट है कि नहीं है? मतलब
प्रूफ इंपॉर्टेंट है कि नहीं? हाँ, इज दैट ऑल?
यस सर, थ्योरम्स का जो प्रूफ है, जैसे कि री एनालिसिस और ग्रुप थ्योरी में जो है थ्योरम्स, सर उसका प्रूफ देखना चाहिए। क्योंकि हमारे पास मल्टीपल चॉइस है, तो आप सजेस्ट क्या करेंगे?
ओके, सो दोनों टाइप के क्वेश्चंस आपको मिलेंगे एग्जाम के अंदर, जो फॉर्मूला बेस्ड है और जो थियोरेटिकल या फिर थ्योरेटिकल नॉलेज टेस्ट करना चाह रहा है आपका, है ना? सो प्रूफ करना इंटरेस्टिंग हो जाता है और काफी फायदेमंद भी हो जाता है, इन विच केस आपका दिमाग स्टार्ट कराने के लिए ना, इट्स लाइक एक्सरसाइज रोज करते हैं, देन फिजिकल फिटनेस टेस्ट देने जाते हैं, तो यू कैन डू मच बेटर, है ना? और तो उस केस में प्रूफ जो है वो आपके माइंड की एक्सरसाइज करवा रहा है ना। सो प्रूफ इज एक्चुअली, या श्योर सतीश, आई यूज इंग्लिश एंड हिंदी बोथ इन
Excuse me, Rajendra.
या सर?
We have many members from Kerala and South India, so it is better to speak in English. And
यस,
all participants also requested to ask your questions in English.
या
Whenever-
श्योर सर, या okay. So where were we? Yeah, we were talking about whether to go for proofs or not. Yeah, so proof are important for your mind's exercise. Okay, formulas are important to do those questions which are totally formula based and you do not have that much time to spend on every question, so they are both important. Proofs are important for your exercise of your mind, so I would suggest to go through the process of the proof and understand it. Do not remember it, try to understand it. Once you have understood the proof, you can move on. In this way, you will remember the proof. You will not have to put extra effort on the statement of the theorem. You will automatically remember the theorem because you have gone through the proof once. So just understand it. Don't just memorize the whole proof. Just understand. That's it. Understanding is enough here because questions are MCQ. Okay. Yeah. Okay. I'm not pinned, is it? Okay.
सर
Yes.
सर जैसे कि बीएससी में सर अभी हम लोग के सर ग्रुप थ्योरी है 5th सेमेस्टर में। तो सर अभी हम जो सर मेरा बैच है इसमें सर लगभग ग्रुप थ्योरी सर कंप्लीट हो चुका है, मैं अच्छे से मतलब पढ़ भी चुका हूँ।
ओके।
और तो अभी तो सर अभी हम लोग 5th सेमेस्टर में एडमिशन होने वाला है। तो सर उसका जैसे ग्रुप थ्योरी है, रिंग प्लस कुछ टॉपिक सर रिंग थ्योरी के है, और सर उस समय उसमें भी एक लीनियर अलजेब्रा टॉपिक है, जैसे वेक्टर स्पेस है, फील्ड है, और सर इसमें मतलब और कुछ टॉपिक। तो सर क्या बैचलर के साथ साथ हम सर अच्छे टॉपिक सर मतलब जैसे जो जैम से रिलेटेड रहता था उससे सर अच्छे से मतलब प्रिपरेशन कर सकते हैं कि हमारा जैम में भी मतलब अच्छा मतलब रिस्पॉन्स करें कि हम नंबर गेन कर सके अच्छे से अच्छे।
As far as your BSc is concerned, so the question is that how to cope up with questions from JAM and BSc together. Like if there is a common topic, like he said that group theory is there in his syllabus, and it is there for in JAM syllabus as well, and it is in graduation as well, and you are in like it is in your syllabus. So if you look at the pattern of both the exams, it's very different. Okay, but the topics are same, very same. So if you're while you are preparing for the group theory, you can find all the theorems in your syllabus. And proofs are important for your exam purpose, and how the proofs are done. If you want to, you have to really understand the proofs, not just remember them. If you are able to understand the proofs, you are able to solve the questions, theoretical questions, and that will do for both of them. So try to understand theorem. That's it. That's all I will say. That wherever there is a theory in your this, and it is kind of looks like an important result, which are mostly important in your graduation. They don't give like so many theorems, very limited theorems, very popular theorems, like Lagrange's theorem is there, like the definition of center is there, that's the center of a group. And then there are some questions related to center, very basic questions. If you do those questions very carefully, try to understand the definitions, I think you can go for the very first step where you do some basic problem on the group theory. So I would say that this you can apply for every topic. Like what generally people do is they go through the theory and then they just go through the PYQs. So it's like you have been through theory and you are just directly going to the exam. That is very difficult to solve and you will get demoralized. Step one would be do some easy problems, do some assignments, some very basic theoretical problems. Okay. And when you're done with those, then you go for the exam. There will be 3 steps. Step 1 is theory, step 2 is basic problems, and then step 3 is exams question. Okay, this is how you should be doing. All right. Yeah. So now I think we should go for some problem solution, and we can take more of your general question at the end of this session. Okay. Shall we? Yeah, if all of you are ready, you can just comment something or just give me some sign that you are there. Okay.
Sir,
Anji.
sir, there is time to ask question. There is more time to ask question than previous question, but some question are taking 4 to 5 minutes to ask, sir, and there is less time.
Yeah, but you are not in exam. Some question might take your 2 hours. That is totally fine. Some question might take your whole day. That is still fine. Okay. When you are preparing for exam and there is only 1 month, then you think about these problems. Right now you spend all the time you have. There are you have almost 200 plus days. You can spend as many days as you want. Okay. Right now the time is not problem. The time will be problem when you are just 1 month away. Then you will have time and speed both. But now you have to spend time. Okay. You can spend time. Don't worry about time right now. Try to pick a problem and solve it. That's it. That's what you have to do right now. Okay, so I have picked some problem mixed of them, and since my topic for PhD is algebra, so I'll do some questions from algebra, and I think all of you are familiar with some of the algebra. Okay, so that will also be helpful so that you can all engage with me for each and every problem. So how will we will do this session? I'll put a problem in front of you. You guys will try to solve the problem. I'll ask any of you if you can try to attempt the problem, and then I'll explain the problem with answer and what concepts are used behind that problem. Okay. If you want
Sir,
to take
आप
notes, yeah.
सर आपसे सर हमेशा कैसे कांटेक्ट में रहे, बट सर क्वेश्चन तो होते हैं, पर सर आपसे कांटेक्ट में रहेंगे तो सर और इजी हो सकता है कुछ क्वेश्चन इसे लीनियर अलजेब्रा के.
Yeah, I'll try to have some more sessions here on the math aspirants or anywhere. Okay, so I think you can find me in the math aspirant group itself, so I'm there, don't worry. Yeah, so let's just start then. Finally, so this was the question in part A of your exam, and algebra, 1 marks, and a very standard question, strictly formula based question. Anyone wants to try to solve this problem right now? Like, if you want to suggest a solution or the formula, anything you remember regarding this question? Algebra and numbers, okay, they are very close friends. Algebra is always interested in knowing how many, what. They will give you a number like this number and then ask you another number. Okay. Anyways, so there is a group. You have GV, a group of order 39. So whenever there is a question from the group theory and it is giving you the order of the group, the very basic thing to do is prime factorize it, the number itself.
Sir, should I try?
Yeah, sure.
Order of group divides order of subgroup. Lagrange's method.
Order of subgroup divides order of group. Yes.
G has 13 elements of order 13.
Okay.
बट सर इसमें जैसे ऑर्डर सर उसका 13 है, तो उसमें जैसे प्राइम है, तो उससे सर कह सकते हैं कि जी नेसेसरली साइकिल.
See, the order is not prime. Okay, so we have to look at the order of the group. So what is the order here? Order is 39, and you don't have to start thinking what are the factors. They have given the factors, so you can write it like 3.13. Okay. Now, if you have been through Solo's theorem, which are not in like not really in your syllabus, then this question is very trivial. But if you have not, then how do you do this? So this is actually a very popular form of a group, which is P multiplied Q. Two primes, one, like two primes are there. So P dot Q kind of group. So from here on, there are two, ways of this problem. One is that P divides Q minus 1. P is the smaller one. And the other one is that P does not divide Q minus 1. Okay. Group of order PQ, there are two possibilities, that P divide Q minus 1 or P does not divide Q minus 1. Okay. So if your P divides Q minus 1, then there are two possibilities, that a group can be the cyclic group, which is ZPQ, one, and the other one is that it is a non-abelian group. When P divide Q minus 1. If P does not divide Q minus 1, then it is cyclic. Always cyclic. If order of group is P into Q, the concept is there behind this, and P does not divide Q minus 1, then the group is cyclic. That's it. The group is cyclic. Okay. Now, irrespective of that, so now I can claim that G is cyclic. You can note down this result. G is cyclic. It's very popular and it will be helpful for you in GATE, NET, JAM, every exam. Okay. So G is cyclic. Anyways, let's leave this part. What question says? G be a group of order 39 such that it has exactly one subgroup of order 3 and exactly one subgroup of order 13. Then which one of the following is true? Okay, which one of the following are true? The order of the group is, oh, okay. So from here, I can claim one thing very clearly. Does 3, divide this? I mean, 3 does not divide 13 minus 1. It does divide. Okay, so we are in this case. So group may be abelian or maybe non-abelian. So now we have to look for more conditions. Group of 39 may be abelian or maybe non-abelian. It will depend on other properties of the group. Okay, it's not here. It's here. Like if I would have given you 15 in place of this, if I would have given you order of group is 15, then you can directly say it is cyclic because 3 doesn't divide 40. Okay, but in this case, this 3, you have 3 divides 12, so it may be non-abelian. But there is one extra information here. So let's use that information and think again. I'll give you one more property. So you can, I mean, these are very popular number. You should have a list like this. Order of group is P dot Q. Okay, and P divides. Control Z doesn't work here. Okay. P divides Q minus 1. Okay, because if P does not divide Q minus 1, then it is cyclic. You don't have to do anything. It's done. P divides Q minus 1. Okay. Then, if first result, if G is abelian, implies cyclic. Okay. Second, G has unique subgroup of order 13. Order Q, the larger one. Okay, Q is the larger one. There will always be a unique subgroup of 3. If G has unique subgroup of order P and Q, both implies G cyclic. Okay, if both of them are unique, P and Q, then it is cyclic. 3, 4. It's rather if and only if. If and only if. Okay. So if group of order P and order Q both are unique, then cyclic. And if cyclic, then both are unique. Okay. If G is non-abelian, abelian group, then number of subgroup of order P is equal to Q. Okay. There will be Q subgroup of order P. Like for instance, if I give you, for example, like if I take 21. Okay. Now if there is a group of order 21, which is 7 into 3, P into Q. Okay. If it has unique subgroup of order 3, then it is cyclic. Okay. Unique subgroup of order 3, then it is cyclic. Okay. Otherwise, if not, then it is a non-abelian group of order 21. If it is non-abelian, then it has exactly 7 subgroup of order 3, Q subgroup of order P. Okay, so these are the results. I think in future, if you have P dot Q kind of question, you can easily tackle it. Okay, So there is unique subgroup of order 13 and unique subgroup of order 3. You can just go for that. It must be a cyclic group. There is no other possibilities. Okay? You can discard this. Again, if it is abelian, then it is cyclic. If G is abelian, then it is cyclic. So see, abelian, then it must be cyclic if P dot Q order. G need not to be abelian. In this case, it must be. Though P doesn't divide, P divide Q minus 1, it may be non-abelian, but since they have unique subgroups, it must be a cyclic only. Okay. G has 13 element of order 13. See, if you have one element in a group, then that element must come with its inverse. Okay. If you have one element in your group, then that element must have an inverse, right? I think that is very clear. Every element must have an inverse. If you take element of order 13, that every element must have its inverse. Okay. Every element must have its inverse. So if you have A in your group, then you must have A inverse in your group, right? If you have another element, let's say B, then B inverse also must be there. And any element of order 13 cannot be self-inverse, because if A is equal to A inverse, then you have simply A square is identity. This simply implies that either A is identity or order of A is 2. So they cannot be self-inverse. Now, can you really say that there are 13 elements of order 13? Every element comes with its inverse. Is there any group in this entire universe which has 13 elements of order 13? No group, not only this group, any group. Okay, there will be even number of elements unless it's order 2, because order 2 element can be self-inverse. So if you have like number of element of order 3, it will always be even. It cannot be odd, because every element will come with its inverse. So it's a pair. Every element comes in a pair. Okay. So there is no group which has 13 element of order 13. No group. Okay. And precisely the number of element of order P in a cyclic group is 5P. So in this case, it will be 5 of 13 co-prime number with 5, since it is a prime, so it's 13 minus 1. So there will be exactly 12 element of order 13. Okay, 2 element of order 3. It is cyclic. I think rest of detail is very clear. Is there anyone who wants to ask any question from this?
Doubt here.
Yeah.
You said that for every A, there will be an A inverse.
Yeah, sorry.
But for every element A, we'll have an A inverse in a group.
Yes.
But A square will be E only if A is equal to A inverse, right? We never implied that A and A inverse are equal. We just said that for A inverse exists. We never say
Yes,
it's equal,
A and
right?
A inverse exists. Yes. What is your question?
From saying that there is an A inverse, we have given above that A square is equal to E. How do we come to that conclusion?
Yeah, exactly. So how did I come to that conclusion? Is I just use simple algebra. See, you have, let's say that there is an element. Okay, there exists an element A in your group G, such that it is self-inverse. If there is an A which is self-inverse. Okay, this implies what? You can simply operate A in the left side and in LHS and RHS, and you simply get A square is equal to A inverse. This simply implies that A square is identity. This simply implies that order of A divides 2. This simply implies that order of A is equal to 2 or 1, because there are only 2 divisors. This implies that either A is equal to identity or order of A is 2. Okay. So if an element is inverse of itself, then either it is an identity element or it has order 2. And in this question, they are asking about element of order 13. So no element can be inverse of itself. They will come with a different inverse. Okay. So element of order 13 in any group will be even. It cannot be odd number, because there will be inverse for every element. I hope it is clear.
Yes, sir. It's clear.
Yeah. Anyone else want to ask any question about this? Okay. Then let's move to the next problem, shall we? So this SN, very popular group. So if you are in group theory, you must know about the symmetric group SN. You should make a small list of finite groups about which you know everything. Okay, if I am doing algebra, I'll do it like this. I should know everything about Zn. How many elements are there? Of what order? It is always cyclic group. How many subgroups are there? How many elements are there of each and every order? Okay. Zn. You will have in your list. You will have K4, plane 4 group of order 4 with 4 elements. Which is non-cyclic. Okay. And then you have UN, the set of all numbers which are co-prime with n with multiplication modulo n. You should know everything about this group as well. Okay. And then you move towards, these are the abelian groups. Then you move towards the non-abelian group Q8, the quaternion group Q8. You should know everything about this group if you are doing your algebra group theory specifically. Okay. Then move to the next. Then you know everything about SN, the symmetric group SN. Okay, like S2, S3, S4. You should remember all the elements. Like these are the cycles. These are kind of the cycles. There are like 10 this cycle, 10 4 cycles. Then I mean like this. You should remember. Okay. If you remember, that will be very helpful for you. Then AN, alternating group, the subgroup of SN. Okay. Yeah. So these are all the group of finite order which you should be remembering. Then what else you can remember? GLNR, the general linear group. GLNF, the general linear group of matrices of order n cross n over a finite field FFP of cardinality P primary. Okay. These group you should also know. You should know everything about Z. You should know about Q, the rationals. Okay. Should know about Z. Sorry, R. Okay. Should know about R plus, R star dot, set of all non-zero real number with multiplications. C plus, C star dot, C plus dot, no, C star, there is nothing as a positive complex number. Set of all complex numbers. These are all the infinite groups which you should know about. Okay. And then you should also know about this direct product G1 cross G2. See, this is how you learn a subject. If you want to learn a subject, you should have plenty number of examples. Can you give me a non-abelian group of order 12? Should know at least 3, 4. Okay. Like how do you get non-abelian group of order 12? One is very simple. A4 is there. Right? What are other non-abelian group of order 12? I don't know directly. So what I can do, I can construct one. I know order of S3 is 6, and I can just simply multiply it by Z6, and now I have another group, non-abelian group of order 12. So like this you can construct. Okay. So you should have plenty number of examples for every every subject, whatever you are going through. If you are going through a topic continuity, you should know some example of continuous function. Right? Anyways, so these are the group you should be knowing about. You can make a list of them and know everything about them. Like how many subgroups are there for K4? How many elements are there in K4? What are the order of the elements in K4? All these information. If you have these numbers, these are like addition and multiplication in algebra. These group which I have written, they are addition and multiplication of algebra. If you want to do algebra, you know these multiplication table, you can do good algebra. Okay. Now let's look at this question. Which one of the following is true for the symmetric group S13? So now what is S13? S13 is set of all permutations on 13 symbols. Like you take 1, 2, 3 up to 13 and you take all their permutation. Or you can say that it is collection of all the 1, 1 onto map on a set which has 13 elements. The permutation is nothing but a bijection from a finite set to finite set. Okay, and S13 as an element of order 42. Yeah. Anyone?
Sorry, sir. Sorry.
Yeah, it's okay. Okay. Now, if you if you want to know that what are the order of the element in Sn, how do you find order of an element in Sn? Anyone knows how to find order of an element in Sn? Like what are the possibility of, you know?
So we can take 2 cycles actually.
What? Repeat.
We can take 2 cycles, disjoint
Yeah.
cycles of order 6 and 7.
Yeah, I mean, like something like that.
1, 2, 3, 4, 5, 6, one cycle. 7 to
Mhm.
30, another cycle. 1 going to 2, 2 going to 3, etc. 6 going to 1. We take
Yes.
one cycle. And 7 going to 8, 8 going to 9, etc.
Mhm.
13 going to 7. Take these 2 cycles and take the cross product. That element will have order 42 in S30.
Okay, yeah, I mean, you are specific to this question. Yeah. So how do you find order in Sn? In Sn, the simple way to find order is that you factorize and, partition n. Okay. And then in that partition, you pick elements and take their LCM. That will be the order of the elements. Like if I talk about a simple, like let's say I talk about S4. Okay. So you'll simply take 4 and you will start partitioning 4. How can you partition 4? You can partition 4 in 1 plus 1 plus 1. You can partition 4 into 1 plus 1 plus 2. You can partition 4 into 1 plus 3. You can partition 4 into just 4 itself. And you can partition 4 into 2 plus 2. So these are the possible ways you can partition for it. Okay, now you take this number 1, 1, 1, 1, LCM is 1. This is element of order 1. 1, 1 and 2 LCM is 2. These are all the 2 cycles and has order 2. You take their LCM. Okay, this is a 3 cycle. So this has order 3. LCM is also 3. 4, that's 4 cycle. And again, one element. So it will be of order 4. So these are the orders. Okay, in this case 2 plus 2, that means you have these kind of element 1, 2, 3, 4, right? 2 cycles, 2 cycles, 2 cycles. But in this case LCM is again 2. So these are again elements of order 2. So you partition the number, and in the partition you take the numbers and take their LCM. That will be the order. Okay, like like that means in S4 there are 24 elements, factorial 4. Okay, and there is no element of order 6 or 5. Right, 5 there cannot be, but there is no element of order 6 even. There is element of order 2, 4, 3, like 1 to 4. Okay, similarly in S5, if I ask you that does there exist an element of order like 10 in S5? Can you answer, any of you? There exists an element of order 10 in S5. True statement or false statement? Anyone? Yeah, D6. Good answer, Rishi. For a non-abelian group of order 12. Yeah, there is an element of order 10 in S5. So what you will do, you will simply partition 5, and you partition 5 so that you get 10 as an LCM. If you want to partition, so I am asking about number 10. I want LCM to be 10. Whatever LCM is, it must contain factor 2 and 5 because these are the prime factors. Okay, and if you add 5 and 2, you are going to get at least 7. So you cannot partition 5 so that you get 7. So there will be no element of order 10. Let's look at this question. Okay, so again, what we will do, we will just partition and then look for it. Okay, so partition of 13 so that the LCM is 42. Anyone? Partition of 13, I have to partition 13 into, and such that the LCM of all those should be 42. Anyone want to answer? Hmm?
6 and 7.
6 and 7.
7 and
6.
7 and 6, right? So if I take 7 plus 6, I'm getting 13. Sum is 13, so it's a partition of 13, and LCM is 42. So yes, I do have an element of order 42 in S13. Okay, so S13 has an element of order 42 your problem is done. You have secured 1 mark, move to the next question. Okay. Right? If it is 1 mark, it's a single correct question. Why would you go here and there? Okay. Now you can select or discard rest of them. S13 has no element of order 35. So now I can 35. I'll prime factorize 35. How do prime factorize 35? There is 5 and there is 7. Okay. So I can have 1 plus 5 plus 7. That's a partition of 13 and LCM is 35. So there is an element of order 35. It is saying no element. Okay. S13 has an element of order 27. Now for the 27, what do I need? The prime factorize in 3 cube. Okay, but LCM of 3 is nothing but 3 only. So I cannot reach there. Onto 27, I cannot reach in any possible combination of partition of 13. Okay. S13 has no element of order 60. 60 is 12 and 5. Right? Can you give me any partition of 16 which, oh, I can just take all the factors 2, 3, 5. Right? These are the prime factors in 60. So I can just add 4. Okay. Is it 13? Yeah, I can have 1. So I can have 1 plus 3 plus 4 plus 5. Okay. So this is 13. So this is a partition of 13. And if I take LCM of these, LCM of 1, 3, 4, and 5, I get 60. Right? Do I? So there are elements of order 6. And what kind of element those will be? 3 cycles, 4 cycle, and 5 cycle product of them. Okay. So like this. So in SN, finding how many what kind of elements will be there, you can just factorize this n and then look for it. Okay, partition of n. Anyone any question about SN? No question.
So the option C, can you please explain once more that 27? Why did not we take 9 plus 3 plus 1?
Yeah, 9 plus 3 plus 1 we can take, and it is sum to 13. Yes, it is a partition of 13, right? But when we look for the LCM of 9 and 3 is 9 only. Okay.
Yes, sir.
Yeah, so it's very common error in exam. So be very careful when you are in exam. So like when you are in in the exam and you are completely in that phase, and then you're like LCM of 2 and 2 is 4, and that's it. It's gone. Okay. So yeah, careful. Let's move to the next problem. So I mean, let's have one more problem from algebra, and then I'll try to put some questions from other subjects. Okay. This I find a really good question. It's from a book. I don't remember the name. I saw this question in an exercise of a book. It was a foreign author book. It was an exercise. Okay. And it says that let G be a finite group containing a known identity element. Now, see, if you look at the question, you are in exam and you don't know some words, like you don't know what is conjugate. Okay, move to the next question. At the moment, move to the next question. There are many questions, you will find those in your range. Don't spend time on those things which you don't know. If you have done all 60, then yeah, you can spend as much as you want. But mostly it's the other way. So G be a finite group containing a known identity element which is conjugate to its inverse. Now, what is a conjugate element? So you need some basic definitions in that case. Right? So I'll just go to the definition of conjugates of an element. Right? So I mean, what is a conjugate? So if you have an element, let's call it X. Okay? So let's say that X is in group G. then y will be conjugate of x or vice versa. It's the other way around. Y is conjugate of x, or x is conjugate of y. It's the other way as well. If you can find a number, an element, not number, an element, let's call it A in your group G, such that x A, oh sorry, I can just handle it like this. Ax A inverse is equal to y. I mean, you can find an element A such that when you find Ax A inverse, you get y. Then y is conjugate of x and x is conjugate of y. Okay, and then you make a new set. We call it class, conjugate class. I think you know, some of you know conjugate class of A. What do? Is you collect all the class of x in this case. You collect all the conjugates of this particular element x. So what it will be that you will take Ax A inverse for all A belongs to the group G. Means you take this x and operate A and A inverse all from both sides, and all the elements that you get, you will list into this set. This will be called the class of, or the conjugate class of that particular element. So every element has their own conjugate class. Okay, so this is a class. Now there are some facts that you should know about class. That the class of an element X, it may not be a subgroup, but the cardinality, the number of element in the class, divides the order of group. Okay, the number of element in a class divide the order of the group. Now what does it say? That it says that it is a finite group, and there is a non-identity element which is conjugate to its inverse. Okay, there is a non-identity element which is conjugate to its inverse. What does it say? It says that there is an element x in your group. Okay, there is some x belongs to G, such that x Ax A inverse is x inverse itself. That's what the given information is, that there is an element which is conjugate to its inverse, right? What are the conjugates of x? Those elements which you obtain by operating all the elements from group A, x A inverse, and group whatever you are getting, that will be conjugate of x. Now so that means in class of x there are at least two elements, x and x inverse. If x is equal to x inverse, there can be two cases. If x is equal to x inverse, this implies that x square is identity. This implies that order of x equal to 2. This implies that 2 divide order of group, because order of element divide order of group. 2 divide order of group. This implies G is even. Cardinality of G is even, or order of G is even. So if the element is self-inverse, then the group is even. So if element is self-inverse, then we can just directly go for the group is even. Again, we are considering that it is a non-identity element. Okay, that's why I'm directly writing x square equal to identity implies that order of x is 2. Could have been identity, but they are denying that it is not an identity element. Okay. Order of G is necessarily even, but if we take the element to be self-inverse, we are getting even, but it is saying that it should necessarily be even, so we cannot actually say anything. G is, there is nothing that we can talk about cyclicity of the group. So G is necessarily abelian. There is nothing that we can talk about abelian either. So I mean, so far we have that if x is self-inverse, then the order of group is even. Let's say, what if x is not self-inverse, and there is an element which is in which is the conjugate of its inverse. Yeah. So now we have x and x inverse belongs to class of x, right? Class of x. And we also have a result that the cardinality of a class, number of elements in the class, divide order of. Okay. Now let's say that there is one more element other than x and x inverse in the class of x. Okay. If there is some element, let's call it y. If y belongs to class of x, this implies that there is some element A in your group G such that A x A inverse is equal to y. Fine. Y is conjugate means what? There is some A such that Ax A inverse, we are getting it to be y. Now what I can do is, if I take the inverse in the both side, what I will get? I'll get, if I take Ax A inverse all inverse equal to y inverse. This implies that I get A inverse is open in the opposite way, right? I think you know this, right? Shoes and socks law. Like you wear socks first and then you wear shoes, and when you are opening it, you open shoes first and then you go for socks or shirt and button. A, and so this A inverse is A, this will be x inverse, this will be A inverse, this is y inverse. So that means that this y inverse is in class of x inverse, right? This y inverse is a conjugate of x inverse, and all the conjugate of x and x inverse are in class of x only. So this simply implies that y inverse is also in class of x, right? So if you have an element in class of x, then its inverse is also in that class. What can you say about the order of cardinality of this class? Can it be odd or it must be even? Anyone? If you have x, then you have x inverse. If you have y, then you have y inverse. These all are in your class. If you have one, then there is an inverse. If you have another, then there is inverse. What can you say about cardinality of this class? Will it be always even? Yes? Anyone? It will always be even now because it's in pair. When there is x, then there is x inverse. Okay. So if an even number divide order of your group, then the group must be of even order, and that's your answer. The group must be of even order. Okay, and you can just incorrect all of them because we have proved it. All right, let's move further and do some more question, but yeah, not from algebra. Okay, or do you want more question from algebra? Hope not. So this question from sequence, you find like almost 20 marks. 20 is like little over 15, I think, almost 15 marks from this sequence and series chapter, where you have been asked convergence and divergence, and there are very limited results which you can apply and get marks for these such topics. If there is a question from sequence and series, and generally you can solve it in like 2 minutes, 30 seconds even. If you are not able to, then it becomes a real problem. It's very difficult in that case, and you should move on. So an is equal to this and bn is equal to this. You have been given two series, and the question is about whether these series are convergent or not. All the questions that we have been discussing are from 2024 paper. This question was of like this was of 1 marks. Okay. Yeah, this is for 2 marks and easy question, I would say, if you know the test. So the very first test I would like to tell you is the P test, and the other one is the comparison test. Okay. So anyone knows the P test? The P test for series of positive terms. Anyone? No. Okay.
Summation 1 by x raised to p is convergent when p is greater than 1.
Yes. Yeah. So summation 1 upon n raised to the power p, n varies from 1 to infinite, is convergent if and only if it's the other way around as well. If and only if p is greater than 1. Okay. If p is greater than 1, it is convergent. If p is less equal to 1, then it is divergent. If and only. Now there is another test called ratio limit form comparison test. Okay, so I'll give you 2 more tests. So I mean, for the series, if you want to find whether it is convergent or not, you should know some tests, and that's what I'll be telling you right now. For the positive terms, there are 2 very popular tests. Okay. Let me tell you. If so, I'm just giving you one which is required for that convergence with this particular series. If an is greater than 0, greater or equal to 0, positive terms, positive will work. Okay. I have precisely take positives only. If an is all an are positive, that means the series is of positive terms. Summation an, a1 plus a2 and so on. It should be of positive terms. If an is of greater or equal to 0 and let's take Bn to be positive true. Bn should be positive. There are 2 sequences which both of them are positives, and limit n tend to infinite. An upon Bn is equal to L, not equal to 0, and finite. Okay. That means that limit of an upon Bn exists finitely. Then summation an and summation Bn converge or diverge together. I mean, if they are convergent, then they will both be convergent. If they are divergent, they will both be divergent. How do you use this to solve a problem? Okay, so I mean, if you look at this kind of problem, like look at this an, you have 1 upon 3n plus 2 and 3n plus 4. I can easily see that there is 1 and 2. So if I expand it into a polynomial form, I'll get n square in the denominator. Okay, and I do know that summation 1 upon n square is convergent because of the P test. Okay, so I have to find a sequence Bn, or I mean whatever you want to call it, because Bn is already there. Let's just not call it Bn for now. We'll call it Bn after solving this. Okay, so you need a, if you can find a sequence Bn such that summation Bn is convergent, like you should know everything about Bn. Whatever Bn you are choosing, you should know about Bn. Okay. So in this case, I do know that I can choose Bn to be n square. Okay. So my an is equal to 1 upon 3n plus 2 and 3n plus 4. And I do know that there is n square in the denominator, the highest power I will look for. So I'll choose Bn is equal to 1 upon n square. This I have selected depending on the kind of sequence. Okay, but I have looked into that what is the highest power, and second that it is of positive terms. It must be of positive terms, then only the test is applicable. Okay. And now I'll look for limit of an upon bn. Let's see what I am getting. So I do an upon bn, that is equal to, so my an is, if I do this all, it will go into reverse. I'll get n square upon 3n plus 2 and 4. So I get 3n plus 2 and 3n plus 4. Okay. And now I take n common from the denominator. There is no difference between this n and the x I wrote before 2 slides. So n and x are almost same for me. I have a bad handwriting, and then the PowerPoint write it in like more worse manner. So yeah, if you are not getting any of it, you can just ask. Okay, so I'll take common n square and cancel it out. So what I'll get 1 upon 3 plus 2 upon n and 3 plus 4 upon n, and let n tend to infinite. I get 1 upon 3 from here, this goes to 0, 3 from here, this goes to 0, 9, which is non-zero. So if I look for this test that an and bn are of positive terms, yes, an and bn both are of positive terms. An upon bn gives me a non-zero finite limit. Okay, so if summation an is convergent, then summation bn is convergent, and vice versa. If summation bn is convergent, summation an is also convergent. And we know that summation bn is equal to summation 1 upon n square is convergent. Why it is convergent? By p test, because we have selected it in a way that we know about it. Okay, so summation bn is convergent. Then by this comparison test, it is called limit form comparison test, where we are comparing two series. We are telling about one series by observing in another series. Okay. This implies that summation an is convergent. This is for positive terms only. Okay, so summation an is convergent. Yes, an is divergent, both divergent, both convergent. We have to look for this and this. Okay, so option 1, this part, this sequence is convergent. There is nothing to worry about this part. Okay, now let's look for bn. In this case, bn is n cube plus cos 3 to the power n upon 3 to the power n plus n cube. Okay, now if I look for this again, this looks like a series of positive terms, doesn't it? See, n cube is at least 1, and cos 3 to the power n is like at most -1. It cannot be -1 ever, right? So even if I cancel this out, it will remain positive. So this is also a series of positive terms. But in this case, you can't use p test because there is 3 to the power n in the denominator. Can I use 1 upon 3 to the power n as my bn if I consider this to be a? So I mean, I will leave this problem for you to solve. Okay, in this case, you take bn is equal to 1 upon 3 to the power n. Okay, and you do know that summation 1 upon 3 to the power n is a GP with common ratio 1 upon 3. So this part is convergent. Now you have to figure out whether an upon bn gives you limit or not. I don't think it will give limit. If I take an upon bn, I will get 3 to the power in the numerator, and I'll be able to cancel out 3 to the power n to 3 to the power n. I'll get n cube plus cos 3 to the power n whole upon 0. It's not working. It is not working. Should I take something else? Like, can I take, in that case I get 0, right? If I take n square with it, 3 to the power n is actually the only part. If I take n here, then I'll get n here. Now, should I take this kind of thing? N cube upon 3 to the power n, will this work? I mean, just creating another problem, having already one problem. Okay, so I'll have 3 to the power n upon n cube. Now I can take n cube common and cancel it out. In that case, it will go to 0. I can't use this. Okay, so we'll have to try some other methods. But I do know that it is of positive terms. So I'll go for the limit form comparison test. Okay, so this is comparison test limit form. There is the actual comparison test which does not include limit thing. Okay, but it is there. So I'll tell you that as well. So you are getting both the tests in this question. What is the other test is the second. This is comparison test. Comparison test. Again for positive series, okay, positive terms. An and Bn both are positive. Okay, positive sequences of real number. Okay, positive. If An is less equal to Bn for all n belongs to n, you can leave some finite terms because finite term doesn't matter in a series. Then first you just simply apply some here and some here. Okay. If summation Bn is convergent, implies summation An is convergent. Second, if summation An is convergent, sorry, summation An is divergent, because we cannot say even if summation An is convergent, the summation Bn is bigger. It may diverge, we can't say. But if summation An itself is divergent, the smaller one is divergent, so the bigger one must diverge. So if summation An is divergent, implies that summation Bn is divergent. So this is referred as comparison test, and this actually is another form of this test only. This is limit form comparison test, where we try to analyze limit A and upon here. Okay. I think I can apply this comparison test here. So let's see if I can. So in the question I have n cube. You can look for Bn if you can find. You can look for Bn, suitable Bn. I leave it to you. But let's just look at this test. I wanted to give you the another test as well. N cube plus I have cos 3 to the power n whole upon 3 to the power n plus n cube. Okay. I do know one thing for sure, that cos 3 to the power n can never be greater than 1. That is the largest value of cos 3 to the power n. Right? Largest value of cos 3 to the power n is 1. So I can simply do this. This thing is less equal to n cube plus 1 upon 3 to the power n plus n cube. Now, rather than checking convergence of this, I can just simply check convergence of this. If this part is convergent, I can claim the other one is okay. And this part you can easily tell it is summation n cube upon 3 to the power n plus n cube, because it's an absolute convergent series. You can just do this, and n cube plus 1 upon 3 to the power plus 1 upon 3 to the power n plus n cube. Okay, so these separately are convergent. You can test their convergence using another test. Okay, I mean I can directly tell because I have 3 to the power n, which is an exponent entity. So it's somewhat like this. Like if I look for, like, just without doing anything, I can just look at this from here, and I just look for 1. This seems to be 1. Okay, so I have n cube plus 1, and then I have 3 to the power n plus n cube, which is almost equal to n cube upon 3 to the power n plus n cube as n tend to infinity. Okay, and then I have 3 to the power n, which is an exponent thing. So this is much larger than this, and you can use a ratio test to solve it, like an plus 1 upon an. If this gives you limit, then your series is, if this is less than 1, then your series is convergent. That is called ratio test. I mean, this is called ratio test if summation an is of series of positive terms, and an plus 1 upon an is giving you limit which is less than 1, then your series is convergent. that is another test. So yeah, this question was of 2 marks, and you needed to know all the tests for positive terms: limit form comparison test itself, and then I am using the ratio test. In here I am using ratio test. To prove the convergence of this, you can use a ratio test. Okay. So you see, if you want to solve the questions from JAM exam, then you should be knowing a lot about it. Okay. Like a theory, a good amount of theory specifically. All right. Let's do one more problem and then we will just, shall we? Or should we finish it up? Okay, I'll do one from linear and then we'll finish it. Seems like you guys finding it difficult. Look at this question. So you have polynomial of degree 7 at most, and variable is x. Together with a 0 polynomial, and t be a linear transformation from p7 to p7, defined like this: the function itself plus its derivative. Which of the following is true? Okay, so they are asking like whether t is onto or not. There is some cases that t to the power k0. What are the eigenvalues of this t? So, I mean, so many questions. Okay. Okay. Now, so what do you do in such scenarios? The very first step is you take the basis of domain. What is basis of domain? The standard basis. Okay. So for P7x, you have 1 x, x square, and so on, x to the power 7. These are your, this is your basis. You will take this basis and find the image of basis under this map. Okay. Let's see what image I am getting. And in parallel, I'll make the matrix of this linear transformation. What will be the matrix? The matrix will be that I'll be writing the coefficient of the, like I'll write in columns, and I'll write coefficient of 1, the constant 1 in first row, the coefficient of x in second row, the coefficient of x cube here, x square here, and x cube here, and so on, like this, x to the power 7. And same thing here, I'll take 1 here, the constant 1 come here, then x, and then x square, and so on, x to the power 7. This is how I'll be making the matrix. Okay. Now I'll find image of 1 under this map. So my 1 is mapped to the 1 itself, 1 plus the derivative of 1, which is 0. So 1 is mapped to 1. So I am finding image of 1, which is mapped to 1 only. So the coefficient is 1, and the rest of the multiples are 0. Right. So my column 1, this is image of this element. Okay. Now I look for x. X is mapped to x itself plus derivative of x. So 1 plus x. So the constant is 1 and multiple of x is 1. Rest of them are 0. So the constant is constant will come here, first row. The multiple of x is 1. Right. Multiple of x is 1. I'll get 1 here. And then rest of them are okay. Take x square, find its image. I get x square plus the derivative of x square, which is 2x. I write it down in your matrix. The coefficient of the constant 1 is 0. The multiple of x is 2, and this is 1. And then I go 0. Okay. Similarly, if I take for x cube, I get x cube itself. That means on the diagonal, I'm getting always 1. Okay. And above diagonal, in this case, I'll get 3x square. So I'm getting 3. So above diagonal, I get 3. So this is 1, 2, 3 up to, like, I'll get up to what? 7 or 6, 7, right? 7 here. And all the diagonal is 1. So this is the matrix. All diagonal ones, above diagonal 1, 2, 3 up to 7, and rest of the entries are 0 in your matrix. Now I think you can answer. That is not surjective map. It's an invertible matrix. If the matrix of a linear transformation is of full rank, it is 1, 1 onto map. It is surjective map. It is injective map. This is incorrect. T is a surjective map. Okay. there exists k belongs to n such that t to the power k is the zero transformation. It's not a nilpotent, it's moreover invertible matrix. T to the power k is also invertible. You can discard this. All the eigenvalues are only one. On the diagonal you have only one. So 2 is an eigenvalue. No, that is incorrect. So C is also gone. I can select D because I have discarded the option. It's easy question. If you know how to make matrix, find image of basis, make a matrix, and you can get 2 marks in your exam. Okay. Look at this. There exists R belongs to N such that T minus I. Now he's doing T minus I. That means these all will become 0. Right? So below diagonal it's all 0. It's a nilpotent matrix. If diagonal is 0 and below diagonal is 0, it's going to be nilpotent matrix. Okay. So after some power, it will be 0. Moreover, in this case, it's exactly t to the t minus I to the power 7 will be 0. It's a nilpotent matrix of index 7. Okay. So this is the correct statement. So in this case, you have D as your answer. I think I have selected some good.
Sir, your voice is breaking.
Yeah, Rajendra, please excuse. I think some network issue with your connection. Hello. Hello, Rajendra, are you there?
Yeah, I'm there. Was it working? Like, was it working? Okay, or was it like gone for a while?
Okay.
Yeah, okay. I thought it was gone. Yeah. So I think we solved enough problems for today. So this was also a good problem. I mean, JAM's problem are like some problems I like them more than NET's problem. They are like really up to good level. Like even competing with TIFR's problems. Yeah.
Okay. I think we can stop the problem discussion for the session now. Of course, I would like to thank Rajendra for this nice session, and I request him to do more problem solving sessions in our platform whenever time permits, because this type of sessions will be really helpful for the participants. Now, dear participants, it is the time for feedback, or you can make you can ask your queries regarding any preparations or anything like that. You can ask now, and also you can feel free to share your feedback about the session.
Good evening, sir. My name is Ramakant. I'm from St. Paul's College, Ernakulam. So today's session was very enriching, especially the part where you explained how to crack JAM exams and the question patterns and all. But for the problem solving part, it was a little bit hard for me as the topics are not yet covered in my college. Hope the after that one I'll be able to understand much more clearly. Thank you for making a wonderful session, sir. Thank you, Vinod, sir. Good night.
Okay. Thank you, Ramakant. Yes, others.
Hello, sir.
Yeah. Yes, Praveen.
Yes, sir. Sir, thank you for the awesome session. Sir, I had a doubt. Is there any substitute for the coaching material for practice? Like, instead of going for any coaching material, can we go for any textbooks, or will the previous years be questions be sufficient, or should we go for any coaching modules?
Yeah. Praveen, I would, if you are very going through the content for very first time, I would suggest you to take it little easy. If you are good with books, then you can easily go for like Malik or Mappa. That will do for analysis part, and this Rising Anya for differential equation, and Hoffman Kunz for algebra. You can also go for Krishna's publication for linear algebra. And for algebra, you can take Galilean is best. You can take Galilean for algebra. So if you are comfortable with books, but again, books are very detailed, and since you are preparing for a competitive exam, you need results to be pointed out. At the same time, you also need practice sets, and the content which is based towards your exam. If you can get those, that will be like a shortcut for you. It will be helpful in a sense that you can prepare much in less time. So otherwise, yeah, books are always preferable if you can do that.
Yeah.
And for content, you can. I have created a website where I keep posting the questions and their answers in exam patterns, like they are multiple choice format. So you can look there for the questions specifically.
Okay, Praveen, that is the point. For making the concepts clear, you can go through the textbooks, but practice of problems is very much needed for cracking these type of competitive examinations. So you should be very familiar with the type of questions that can be expected in these type of exams. Yeah, yes, thank you, Praveen. Yes, Indraja. Yeah. Yes, Indraja.
Hello, sir. Hello, sir. My name is Indraja. I am from St. Teresa's
Yes.
College, Ernakulam. So, sir, this was our first official session of JAM coaching from Aspirants. Sir, thank you, Rajendra sir, for the session. It was really interactive and easy to follow. My personal favorite was real analysis. It was really interactive. I would also like to thank our Vinod sir for organizing this session with Rajendra sir. Thank you, guys. Thank you so much.
Okay, thank you, Indraja. Yes. Yeah.
Good evening, sir.
Yes.
Good evening, sir. I am Aglaji Suresh from St. Teresa's College. First of all, thank you, Rajendra sir, for this wonderful session. And also, I thank Vinod sir for giving us this opportunity to attend this class. During this session, sir gave a brief info about the JAM exam and cleared our concerns and doubts about it. He also shared some strategies for preparation. About the problem solving section, it was a little hard for me, but in my mind it was running like, Agila, okay, if you study, concentrate and practice more, you could do it. Like that, I was feeling like that. So once again, thank you, sir. Thank you.
Yeah, thank you, Akila. Your thoughts are in the right direction. So such kind of positive attitude should be there for everyone. Yeah, at the first moment, it may be difficult to catch up the problem solving, but we will provide the recorded version of this class. You can go through it again and again and learn the things. So don't lose your mind by saying that if at the first very moment you are unable to crack the question, then don't go down. Okay.
Yeah.
Thank you, Akila. Yes, others.
Hello, sir.
Yeah, yes.
My name is Rishchand. I am from Government College, Mageri, Kozhikode. First of all, I would like to thank Rajendra sir to explain about the JAM exam and also discuss the questions. Also, I would like to thank the organizer who arranged this program, because this is my first official class or meeting I have attended about JAM class. This made this gave me some directions to prepare how to prepare JAM exam. Also, once more, I am thanking you everyone. Thank you, sir.
Okay, thank you, Rishi Chand, and all the best, all the very best for your preparations.
Thank you, sir.
Okay. Now, any others? If any, yeah. Yes,
Good evening,
Gopika.
sir. Sir,
Yeah, good evening, Gopika.
yes, my name is Gopika Sunil. I'm from St. Thomas College, Thrissur. So, first of all, thank you for this wonderful session. Like, I'm going to attend JAM this year, and your instructions at the beginning, it was very useful for me. Like, I have a doubt. While studying a topic, should we stick on to a single book, or like during the first read itself, should we go through multiple books?
I think if you are considering a particular topic and your goal is to understand the topic, then I don't think you should be limited to a book. As if you want to understand it more, like you are not getting it from a particular book, then there is nothing wrong with going to another book, or even going to someone to ask for that particular topic. Like you can ask someone, take help, and even you can just find it on YouTube or anything. So as far as a particular topic is concerned, yes, you should go for as far as you can go, unless you get it. Okay.
Okay, sir. Thank you.
Yeah.
Yeah, Gopika, it will be better to go for other books because in other books you will be getting more different interpretations of that, more different examples will be there, different problems will be there. So it will make your learning more interesting, and yeah, your knowledge will be get into more depth. Okay.
Thank you, sir.
Okay, thank you, Gopika. If any others would like to share your feedback, please do it now.
Good evening, sir.
Yeah, it's Vanadi.
I'm Vanati from PSCR Krishnamal College. This session was very useful for me, and this session gave me an idea how to solve this question. And this year I'm going to appear for JAM exam, and the topic I wasn't learned it before, so the question was something difficult for me, sir. So please bring more session like this that will help us.
Okay, thank
Thank
you. Thank you, Vanadi. Yes, Adilakshmi.
Yes, good evening, sir.
Yeah, good evening.
Session. I'm Adilakshmi from Rajasthan College, Pondicherry. It was a useful session you created for me and lot of us. Thank you for the session.
Thank you. You're welcome.
Okay, thank you, Adilakshmi. Any others?
Good evening, sir.
Yeah.
I'm Varada from PSCR Krishnamal College. So I felt the session was really beneficial to me. Like sir provided many clear and effective strategies which we can use, like while covering all the syllabus for the JAM exam. And also the problem solving part was also very much helpful because we got many insights, like many practical insights, like which we can use while solving some problems. So thank you so much, sir, for this wonderful session. And also I would like to thank Vinod sir and math aspirants team for organizing such a wonderful session. Thank you.
Okay, thank you, Varada. Any others?
Sir, will you give question solving session for linear algebra separate?
Yeah. Yes, Adilakshmi, are you there in our WhatsApp group? Otherwise, join there. We will certainly arrange more sessions on different topics, which will be useful for your JAM preparations.
Okay, sir. Thank you. Thank you so much.
Okay. Yeah, Isha, you can speak now.
Good evening, sir. I'm Isha from St. Joseph's College, Kozhikode. So, for me, this session was very useful. Like, I was trying to capture everything that I can get from this because the questions were a little bit hard for me because I'm just starting to do more problems and getting into more deeper into this type of these areas of mathematics. So, yeah, so I was trying to get everything I can from the session. So I'm sure that if we get more sessions like this, it will be really useful for us to concentrate more and all. So thank you, sir, for providing us this session, and thank you, Vinod, sir, for organizing this.
Okay, thank you, Isha. Okay, now let us wind up this session here. So once again, I would like to thank Rajendra for this nice session, and I request you to be with our Math Aspirants team, and please do engage more. Please do handle more problem solving sessions in our platform. That will be certainly beneficial for our students. And also, I use this opportunity to wish all success in your research career.
Thank you.
Okay, thank you everyone. Let us wind up here.
Yeah, thank you everyone.
Thank you, sir.
Yeah.
Thank you, sir.